Good morning, everyone. Thank you so much for coming on to the tech stage today. We're really excited to be sharing a lot of the different insights from our panelists today. A very, very brief intro. My name is Kelvin. I am one of the core contributor for Taipei Blockchain Week. And for my day job, I am a product manager at Coinbase, and specifically I work on institutional USDC. So a shameless plug, if anyone's interested in chatting with me about that, feel free to catch me walking around the tech stage. So a very, very brief 10-second intro about this stage. So as you may know, this is the tech stage. The point of the stage is to dig in deeper into the technical side of crypto. But with that said, we will also make sure that we at least briefly intro some concepts so that if you are brand new to crypto, don't worry about it. You will learn a lot about the different topics that are happening. Without further ado, I will introduce the first panel. Also, I don't know if I mentioned, I'm the MC for today, so you'll hear me a lot coming on doing these brief intros. Cool. So for our first panel, it's called The Scaling Horizons, Layer 1's Role in Web3's 2024 Landscape. We'll start off with the literal foundational base layer of our crypto ecosystem, which is the Layer 1's. So think of your Bitcoins, and those are the Layer 1's. For this panel, it's going to be moderated by John, co-founder of Supra, Jerome, the APAC ecosystem lead at Aptos, Justin, core contributor of Solana, and David, Managing Director of TZ APAC. They will explore how Layer 1 companies are innovating and scaling to meet the future demands of Web3, emphasizing their strategies for growth and ecosystem development in 2024. Please welcome the panelists.
All right, how's everyone doing? We got a great crowd here. For those of you that are visiting Taiwan, welcome. This is an exciting day. I'm happy to be moderating probably one of the best panels at Taipei Blockchain Week. And we have a really good crowd here. Of course, we just did the introductions, but we have Jerome from Aptos Foundation, Justin, a core Solana contributor for the last 4.5 years. That's a long time. And as well as David from Tezos. So it's really, really great to be here. I'm John Jones, the co-founder of Supra Oracles. And yes, let's get started. So there's a lot of, so this is an L1 panel. And automatically we're thinking, of Ethereum, kind of like automatically my first thought, maybe some of your first thoughts are how Ethereum is deciding to scale blockchains. We're seeing the rise of L2s, even L3s. It's getting quite crazy. I'm sure we'll see L4s in the future for some reason. But this panel, really, I'd like to focus on different levels of how L1s are choosing to scale. So there's different thesis of modularity, which is from the Ethereum side, versus monolithic blockchains. So L1s that can scale essentially on their own through different ways. And so we'll go into that in depth. But I guess my first question to the panel here is, well, how does Aptos or Solana or Tezos, how are you able to scale? And is it any similar to how Ethereum scales with L2s and L3s? Or what is the specific scaling techniques that you use? Maybe we can start. I kind of want to make this a little bit conversational, so we can kind of maybe we start with Justin from Solana, and we can go around.
Sure. Yeah. So I think Solana is like the poster boy for monolithic blockchains. So it would actually be really awesome if we would have had Ethereum up here too with all of us. But yeah, I think Solana has always was created with the idea of how can we make this blockchain as fast as possible. So there's a number of things that Solana does that enables it to scale to a high number of TPS and throughput. One of the biggest things that you should be aware of is like that Solana by default supports parallelizing transactions. So this is opposed to many other chains where like if you're running a transfer of some Dogecoin to someone else, like your transfer is the only thing happening on like the Doge blockchain. Same with Bitcoin. If on Ethereum you're doing something on DeFi, the only thing in the world happening on Ethereum base chain is your transaction. But on Solana, we can have, for as many cores as like a validator node has, you could be running multiple different smart contracts as long as they don't conflict with each other. And we do that by making every transaction say what type of accounts it's going to use so that the scheduler can make sure that transactions don't use the same accounts when they're being processed at the same time. So that's one of the main things that Solana does, and I think there are a few other chains. I think that Aptos as well does some parallelization. Like newer blockchains are doing that, but it's really hard. The EVM is not designed to be parallelizable. People do something called optimistic parallelization, which maybe we can talk about later. But and then I would just want to say one more thing that Solana does, which is kind of different from other chains, is we do kind of like optimistic processing of blocks. So on a lot of blockchains, when you have a new block, you wait for everyone to agree that like that block should be accepted by the blockchain. But on Solana, we don't wait. We kind of like do that asynchronously. So we might have like, we produce block 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then finally we confirm block 1. And then that allows us to not wait for everyone to agree on block 1. We've already processed 10 blocks in that time, whereas on Ethereum, you would wait maybe 20 seconds, or maybe it's not that long, but some amount of time before you confirm the block, and in that time you're not processing transactions, so that affects scaling too. So those are the two things.
Okay, great. I have a further question later about kind of like the fast chain metrics of different chains and what's most important, block time, finality, but we can get to that later. I think when we talk about parallelism, it's an easy kind of transition to Aptos. Jerome, maybe you can talk about how Aptos, and we had a brief conversation about block STM, about how Aptos is your solution to scaling.
Sure, thank you. So maybe a little bit of a history lesson before that, right? So I think like the Aptos network and how it came about as well was, you take Aptos Labs, the CEO Mo Sheikh, as well as Avery Cheng, the CTO. They were the original part of the team of the Facebook/Meta Libra DM blockchain, right? So I think for people who are familiar with that, that was billions of dollars and years of research going into not just the chain itself, but realistically the consensus mechanism behind it, the Novi wallet. And a lot of large institutional resources went into the R&D of having that chain. For obvious reasons, I think that didn't really come to light. And Mo and Avery got the green light from Facebook, and then became Meta to kind of like spin this off by themselves, raise a whole bunch of money, and kind of like build the fastest kind of chain from incorporation all the way to mainnet launch. Right? I think it took them about 8 to 10 months thereabouts. So I think with that approach, what they've found, and what thinking back about like what the Libra and the DM blockchain was meant to be doing was to process a lot of the financial transactions that you look at, scalable solutions like Facebook that we all know and Instagram uses. So the Aptos network was really built for that in mind. How do we scale transactions across billions of users for financial transactions, social media usage, and whatever use case they might be in the Web3 solution, right? So again, then the underlying consensus as well as the scalability of the blockchain becomes inherently important alongside security as well. So what I'm trying to say basically is then that I think you look at what the Aptos network is doing today is a lot of focus on modularity. We believe that the technology that will come might not be here today, and we're doing a lot of work in terms of the research and upgradability of the core blockchain itself. For example, the trilemma should not exist. So how do we kind of solve for that, right? So that approach then takes into account the modularity of the blockchain and how do we kind of scale for the future.
I think we have to, there's a few times in life where I guess we could thank Facebook for what they've done. But the Move programming language and the original Libra team did come from Facebook. So a lot of research came from those billions of dollars from Facebook. So thank you for that. But yeah, so I mean, Justin, you were saying that a lot of these newer blockchains, they're able to scale because they're not EVM based. And I know Solana is kind of a derivative of Rust. And Move is also kind of a derivative of Rust as well. But we can get into that a little bit later. I'll let David, I want to see from Tezos's point of view, because actually, yeah, I'd like to learn more myself. What is Tezos' way of scaling blockchain? Is it any similar to Ethereum's way, or is it closer to what Solana and Aptos do?
Yeah, so one of the very core fundamentals for Tezos is that right from the start, we have on-chain governance. And that's key for, for the blockchain to adopt any of the technologies that we see are working. And something that we really see that's working really well is layer 2s. And optimistic, ZK rollups, these are all really fantastic technology, and it's a method for the layer 1s to actually scale up. So something that we are doing right now is that we are actually creating multiple layer 2s, and our layer 1 is already ready for layer 2s. And how we scale is that we're not just scaling the number of transactions, but we're also looking at how do we get more developers, developers that know Solidity, developers that know all the different languages, not just blockchain languages, to be able to develop and actually create stuff on the blockchain itself. So I think that's one way of scaling. There's also another sort of idea that we in the ecosystem people are toying with, is that instead of a horizontal scaling mechanism where you have different layer 2s and you have multiple layer 2s to actually scale up, what you do is that you create one giant layer 2 and you compress the layer 1 to just do the fundamental key items, which is just consensus mechanism, censorship resistance, while you have this layer 2 where it's just focused on performance. I think that's also an increasingly talked about method of scaling, and that's something that we are looking at as well.
Okay, great. I mean, so when I look at the EVM ecosystem, right, you see all these L2s come up, and there's this economic incentive to kind of create these different ecosystems, and it's like I saw this tweet the other day. There's one big Solana event per year, but Ethereum, you can have hundreds. How many ETH, Taipei or ETH Japan, or how many of these events do we have every year? And of course, all the L2s combined, thousands of events, and it definitely, I don't know, maybe it fractures attention and liquidity, but it's definitely growing, and there's some incentive model for all those events to happen. Maybe there's some opportunity cost there, but we'll see. But I mean, from Solana and Aptos, when we talk about L2s, is there a future where it would be needed, or is this absolutely not necessary for Solana? And I'll let either one of you just jump in, or Aptos.
I'll take this first. Yeah, so I personally believe that there is a future for layer 2s on Solana. I think it's going to be hard to implement on Solana, but I think that it's possible, and I think at some point block space is going to get filled up, and people will want to move their compute and application usage to somewhere else that doesn't need to fight for block space, even if it is parallelized and relatively low fees. Eventually, if you try to get the whole world using one blockchain, it's not going to work, obviously. But one thing that I think is kind of interesting, not necessarily about Solana itself, but about Ethereum and Ethereum scaling solutions, there's actually some teams that are working on using the Solana virtual machine to scale EVM chains. So there's one that is built on I think one just is building an Ethereum layer 2 called Eclipse, and then I think there's another one that is building on top of SEI, S-E-I, called Nitro. Hopefully I'm getting that right, but it's kind of interesting that they're taking the concepts of the parallelized Solana virtual machine and bringing that over to the Ethereum ecosystem to provide some more scaling there. So I think it's really hard to predict the future right now, but there's going to be some weird mutant combination of different technologies that ends up making everything scale far into the future that we just can't predict right now.
I'm looking forward to that mutant technology.
No, yeah, I think I agree with what Justin was saying. I think about like layer 2s. Never say never, right? I think on Move as well and on Aptos, we do see certain layer 2s already being researched and being built on top of Aptos. And on the Move VM, I think they just see Move as a superior language compared to what's available out there, and then that's why they want to make use of the Move security features and scalability to kind of implement them to other chains, right? In a way. So, but I think back to that first point as well. We talked about block SCM implementation that allows the Aptos network to achieve up to 160,000 TPS with a single core 32 core machine, right? So, do you really need an L2 for that? I don't know. At least that's my answer. But I think when you look at what the engineers at Aptos are focusing on today, like storage layer is still going to be a problem. Today, obviously, with the amount of block space that we have, it's fine, it's working well. But I think as we kind of plan towards the future, and we want to bring on board new users, new billions of users onto the Aptos network, then this is something that we need to kind of like solve for, right? So we're starting to think about that and ways that we can implement better storage solutions for the chain.
Okay, great. Yeah, I almost want to jump into a different question about programming language like Move, Rust, and Solidity. But I think first let's go. Like I know I did have a question about fast chain metrics. What makes your L1 chain fast, and what are the metrics that we need to think about? Is it block time? Is it finality? What are the certain metrics that Aptos, Solana, Tezos really promotes number one? And let's start with Tezos because I'll give you a chance to speak, David.
Hello. Yeah. So something very interesting was that earlier, Justin and I we were having a conversation about how do you actually scale? What's the consensus mechanism? How do you increase finality and everything? Decrease finality and everything. I think that itself is, I think the number one thing that people always look for is always performance. And performance is how can you do things more efficiently and cheaper? It's when you buy a car, of course there's the fancy sports cars, but most of people would actually be like, okay, what's the sort of miles I can drive per liter with this car? How was the effectiveness? I think that would always be one of the key factors in terms of adoption, in terms of whether it's attracting liquidity and whether it's which chain they will be on. So that's one. I do think that there's a second area which is also about security, about the security of chain, because going back, if people are going to put billions of dollars on the chain, what's the form of security that the blockchain provides to actually ensure that they know the money is safe over there? Is a 51% consensus enough, or should there be is there a better method behind that? I think that's very big questions, and yeah, I think and in terms of just increase in terms of actually increasing the finality and everything, right? I think we actually went to more of a philosophical aspect about who do we want to run nodes? How much does it cost to actually run a node? Do you want people to run a node on a Raspberry Pi? Do you want people to be able to run a node on Tor? What's the benchmark that everybody can agree on or at least accept for each chain? That and I think that will actually determines the performance of the chain, because what's the minimum standard? I think
it's funny because back in the day, back in 2017, I was thinking, well, wouldn't it be great if we could have a fully decentralized blockchain that utilized cell phones to validate? But to be honest, this is probably close to Solana. You sometimes really need fast machines to operate efficiently and correctly, and mobile phones it might not be the answer in this case, or Raspberry Pis, right? Okay, cool. I mean, I know Solana became really famous in the last bull market for being the kind of high frequency trading L1, the fastest chain. But I know that there is some discrepancy here because like when we talk about the trilemma, and you said Aptos potentially solved the trilemma. That's pretty cool. That's an awesome statement. But from Solana, I know that like there is sometimes a difference between like sub-second block time and finality. And what does Solana really look at in terms of solving this trilemma, finding this balance between security, speed, performance, and what are the future steps for Solana to achieve this fast chain metric?
Yeah, there's a lot of things that need to be done still. I think to your point, like yeah, Solana has focused on speed, but then we've had a number of outages due to stability issues, and so like sometimes going slow is going fast. Like we need to make sure that the base chain is stable, consensus is stable, so that we can consistently be fast. Another thing that Solana has been doing is like there's a team called Fire Dancer, if you guys have heard of it. Fire Dancer is a team from Jump, which is like a hedge fund. They are working on like a very fast version of Solana. And so while the Solana Labs team is working on making the current implementation, both fast and stable, the Jump Fire Dancer team is making it like super fast, and then I expect we'd see that to come online, sometime over the next few years. But you can only go as fast as is safe, to kind of your point. But I think another thing that Solana's working on right now is we're like making like one way to look at speed is like just like transactions per second, but really what you want is like how much useful stuff are you doing per second? If you're doing a very complex transaction, maybe you're only no chain's gonna do more than like 100 of those per second. Versus like a simple transfer, maybe most chains can do 100,000 a second. I don't know. But for Solana, we're really focusing on making sure we can cut down the cost of doing anything useful as low as possible. So you can kind of think of it as like how much, like on Ethereum, you have this concept of gas, which is like you can only do like, I don't know, I think it's like maybe 50 million gas, use 50 million gas in like a block or something. Gas is measuring useful compute, right? And in Solana, we have compute units, which is a very similar concept. And so our goal is to make it so that each compute unit can be processed as fast as possible. So we're redesigning our smart contract virtual machine to like, it's going to be now version 4, and it's going to probably be like 10 times faster. Don't quote me on that, but I mean, it's just right now there's a lot of overhead in setting up the VM each time, and it'll just be way, way faster. Yeah, so I think there's just a lot of things that we need to do, but obviously keeping in mind security. And then one more thing, sorry, I just remembered you asked about finalization. So when you have finality on a blockchain like Solana, I already explained, like we process a block and then kind of later verify that or like vote on that and reach consensus on it. We have what's called like an optimistic confirmation of blocks, which does take place within like usually within like a second or two. But it's not like a necessarily very consistent metric. Sometimes it takes maybe 20 seconds to confirm. So I think we would really like to be able to get that to be like a more stable confirmation time, because it's a better user experience. But yeah.
Yeah, I mean, we're all building, and like you said, we're going to create some mutant, consensus algorithm, in the future that eventually helps us all solve the trilemma in the best way possible, right? And from Supra's standpoint, we do think, we do think finality, time to finality is quite important, especially in Web3. when you're dealing with when you're dealing with assets of value. Everything in Web3 is based off of value, right? And so, from an Oracle perspective, when we deliver data, we want to make sure that that data is finalized because, for example, a price feed. If you feed someone the wrong price feed and it's not finalized and you have to kind of reverse back, a DeFi protocol that received that price feed could get some user of that DeFi protocol could get liquidated based off of potentially incorrect data. So I think it is important that we all think about finality, and I'm kind of pushing it that way. But I would love to hear from Aptos and your perspective of what are the real fast chain metrics? What is your way of solving the trilemma in the best way?
Got it. Yes. So I mean, John and I were talking about like the finality question as well earlier when we were in the wrong place, but
we went to the it's not working. Okay. Yeah, we actually went to the wrong stage. They led us to a different stage, but happy we made it here.
So I think with that, like Mr. Ari had an independent report that they published earlier this year, I believe, where Aptos is the only network that has a sustained performance of a less than sub-second, basically a sub-second time to finality of somewhere around 0.9 seconds. So I think that's one of the key metrics that we look at, of course. But again, back to the conversation around TPS, right? I think this is something that we always like to break down further, because when you look at TPS, it's not really TPS that you're looking at, right? A lot of this hand-wavy gestures that go around TPS matrix, but what you're really interested in is peak TPS, because again, like blockchain transactions are not linear or evenly distributed. They happen in peak periods, and the network needs to be able to sustain that to get through that throughput. I think second is also how we count transactions. At Aptos, we hold ourselves to a higher bar. We only count transactions that are user-generated. That is a sequence of basically one or more actions, right, with one signature. So I know that some blockchains also define this differently. So we don't count system votes, for example. We don't count metadata updates, things like that. So to us, that's kind of like the most important. And I think with that in mind, then you again, right, back to the billion people conversation about like bringing on board billions of users, we have managed to kind of sustain the network for a 24-hour period with a peak TPS of 25,000 TPS over a 24-hour period. So that brings us to somewhere around like 2.1 billion with the B transactions in that entire window. And I think for comparison, right, like VisaNet basically processes about 150 million transactions per day.
So we're going to go back to, I mentioned earlier, we would kind of talk about programming languages a little bit and kind of the differences between different ecosystems. Of course, Ethereum through Solidity and all these L2s, Solidity has become one of the main programming language of blockchain. It's probably the #1 at the moment. But I think for L1 ecosystems, it's really it is as important to have a programming language that can be highly adopted, right, for developers. And so I guess my question to each one of you is, well, what specific programming language does Solana or Aptos or Tezos utilize? And what is each of your ecosystem's goal to kind of make that programming language standard or more standard in the blockchain space, so you can get more developers to build in your ecosystems? And I understand, like Justin, you mentioned that even some people are building using Solana's core, like proof of history or consensus, and actually building, like allowing people to build in like Solidity, for example. But yeah, just maybe anyone can jump in onto this question about programming languages and how you build out your ecosystem, developer ecosystem.
Yeah, I'll start with my personal thought about some of these languages. So if you were to kind of map out like how secure a programming language is for writing smart contracts, maybe start from here, like the least secure, I would say like Solidity. I don't know if there's a lot of Solidity programmers here, but I will say I've never programmed in Solidity myself. I learned it long ago, but there's been so many hacks and issues with creating secure contracts in Solidity. So I would say it's like not the most secure, and we've learned from them. I think like writing contracts on Solana with Rust it's like it's pretty okay, not perfect. And then you have Move, which is also not perfect, but it's has a lot of nice properties that makes it more secure. So Solana supports Solidity inside what's something called Neon. Obviously, it supports Rust, and I think there's still efforts to support Move in the future. I'm not really sure, but yeah.
Is that some alpha? Yep. Potentially, Solana might support Move in the future? Or?
Maybe. I'm not really sure. I know there was efforts to work on that, but I just don't know what the status of that is right now. So.
Okay. Thank you for that, Justin.
We have like 1 minute, so we have to go a little bit fast here, but yeah.
Sure. So I think, yeah, to Justin's point as well, like the way, again, right, the whole history lesson are like billions of dollars in research going to like the Move execution and research and development of that. That's still ongoing. At Aptos Labs, we still have a core part of the entire Move research team that is still working on the future of Move, right, not just for now. I think we've taken an approach that there is a trade-off inherently between being EVM compatible, the liquidity that comes from EVM today, versus what's the grander vision, the bigger pie of what we think Web3 and the blockchain space could be in the future. So I think that's what we at Aptos have taken that approach to do, right? To kind of like build for the long term, build for the future, to make sure that we take active steps to kind of get there. So that's kind of what we're doing, through partnerships with like Microsoft GitHub, for example, with the Copilot, making Move more accessible to the general public, doing a lot more, programs with universities, researchers, to look at Move and look at Move education in general. Not just for the blockchain space, but eventually also for the Web2 space as well.
Okay. And Tezos?
Yeah. So Tezos, we have the Michelson language, and that has actually formal verification inbuilt into that. So that allows people to sort of mathematically prove that whatever they're coding, everything is fundamentally sound and yeah. But I think actually addressing your questions about how do we actually get people to adopt it. I think rather than that, one of the things that we're looking at definitely is actually how do we allow a certain single chain to have RPCs indexes to actually allow anybody that has any sort of developer knowledge, whether it's Solidity, whether it's Python, to be able to build on the Tezos blockchain. So that's how we actually approach it, rather than saying we have to actually go about not just building a blockchain, but creating a language and getting adoption for the language itself.
Okay, great. This is a great panel. Thank you so much for the speakers. We have Solana, we have Aptos, Solana, Tezos on stage, Supra. Thank you guys so much. This has been a great panel, and yeah, thank you Taiwan Blockchain Week. Woo.
Thanks everyone.